let me begin by explaining why I am doing what I'm doing. And that's basically the age-old question of whether war is a science or an art. And we already heard this morning that war is not only a science but also an art, but at least where I come from, it has been an art for centuries, mainly because many proponents of war and generals see themselves as artists because it's better to be an artist than to be a mere scientist. That's basically what Graf von Moltke says, the left-hand side. So war is an art, warfare is an art, and we have, of course, supporting sciences, and in his time he was thinking about civil engineering and ballistics mainly, and all these mathematics you need for navigating warships, and these basically support war as an art. Now comes my Clausewitz quotation, because Clausewitz made it more precise why war has to be an art rather than a science, and that is because war changes every time. The chameleon that war is means that we only have a single data point at each specific point of time, because we cannot extrapolate from one experience of war to a general picture of war. And that, of course, means that the usual tools of quantitative science cannot be applied, and war has to be a science, and wars can only be analyzed in hindsight by historians. That's the basic idea. And I am an economist, or I used to be an economist before I became president of my university, and I'm obviously dissatisfied with that state of affairs. So what I'm going to do today is to show you how wargaming may help to reintroduce science into the analysis and discussion about war. And these are my three main points. I think that wargames are too much a tool of training as we use them nowadays, rather than of analysis and of research. And then I want to introduce you to the idea of laboratory wargames. What can this be? What is this? And actually I've brought a laboratory wargame, which we introduced for the NATO conference Win24 this September. And I'll finally show you a couple of empirical results from running this experiment. Now, to start with, what is a wargame? Simply, I define a wargame as a simulation with human input. So you have a computer simulation or a tabletop simulation, doesn't matter which, and you allow humans to interfere with the machinery that's rolling on. At some point of time that's well defined, and usually people can have a set of courses of action or other inputs that they can place into the system, and then the system acts accordingly. That's a wargame. And wargames can be used in quite a few fashions. And as I'm an economist, I already told you that I like to think, to organize my thought in terms of matrices. So I brought you a matrix. The vertical levels are borrowed from Thomas Hobbes. Basically, we can talk about Handlungsebene, the level of courses of action, of separate decisions. We can talk about the level of rules, and we can talk about semantics, sir. Thank you very much. About the way that we talk about the rules. And that itself becomes a matter of analysis. Okay, and now the horizontal line shows you what we can use wargames for. There's the obvious application, which is training. Then there is the less obvious but well-used application, well-understood application, which is analysis. For instance, the COPD demands that you wargame your operational plan after the planning phase, essentially, and there's a formal way for reintroducing the consequences of the wargame into the decision-making process. That's what I mean, support of decision-making. And then we have research, which is basically what you see there. And I want to take you into the yellow field for the next 10 minutes, laboratory experiments. Okay, and to set the tone for that, let me start by introducing the Blotto game, which goes back to the 1920s, written by the French mathematician and philosopher Benoit, who came up with the following idea. Suppose we have two people competing, and both of these people have the task of writing a list of 3 numbers in ascending order, so from the smallest to the largest numbers, and the numbers that they write down must add up to a given total number, okay? And I give you here, and the person who has a higher number in 2 places of his list than the other person wins the game. These are the basic rules, and I brought you an example, the simplest one from Wikipedia, obviously, for r equals 6, so you have to distribute a total of 6 over 3 slots, and there's just 3 possibilities, 1, 1, 4, 1, 2, 3, and 2, 2, 2. And if you look at these 3 possibilities, courses of action, you will see that the first one is worse than the third one, and that the third one never loses. So we could say that the third option is a rational choice in this game. Unfortunately, it doesn't stay that simple. As you make the total larger, you will find that the what we call Nash equilibria disappear from that situation. So it becomes very complicated very quickly. And also in the 50s, someone at the Rand Institute recognized that this is obviously equal to distributing battalions among 3 mountain passes. So the idea is you defend 3 mountain passes, your adversary attacks 3 mountain passes, and whoever has a numerical superiority in 2 of the 3 mountain passes, or in just a single one, there's variance on that, wins the game, for obvious reasons. So we have already the idea of allocating resources, military resources, amongst competing uses in this game. And we quickly, the game theory community quickly used this. So there's a General Lotto, there's a Lieutenant Colonel Blotto. All numbers of Ottos are working with problems in that kind of game theoretic setting. Now, what I did for Win24, I don't know if any of you visited the conference or the one in Rome last year. I happen to know the then Deputy Chief of Staff of the German Armed Forces rather well, because we went to our military academy together back in the 80s, and he expressed his discontent with what he saw in Rome, and I said, okay, I can do better. And so I got the task of addressing the strategic level in wargaming. And we came up with that idea. Now, what is that? We call that extended Blotto. And let me introduce you into the basic setup of the game briefly by using these visuals. So on the right-hand side, you see the military sphere of extended Blotto. There's 4 dimensions or domains. I don't care how you call them. And this is obviously a graphic that I blatantly stole from a very famous YouTube personage who also works at this institution currently. You have 3 standard dimensions, can think of them as land, water, and air, D1 to D3, and you have a cross-sectional dimension, Q, which acts as a force multiplier. Okay? And your main task is to allocate your resources to one of these 4 dimensions. And if you achieve a superiority of 3 to 1 in any of the 3 conventional dimensions, you win against your opponent. So that is the upper operational, lower military strategic level of this game. In the middle, you see the hybrid game. So if you say, I allocate, let's say, 2 battalions to Lithuania, it won't necessarily happen, because there's a loss function that increases in the difference between your policy and public opinion. And your opponent can invest resources in shifting your public opinion. So the evil enemy can shift the yellow triangle to the left, and that makes your redeployment harder, because if you say, I send 1,000 men, and the yellow triangle is far away from the orange one, then basically you can send effectively only 500. That's the idea. And that is increasing in a non-linear fashion in the distance between the 2 points. And finally, this is a dynamic game, so we have the economy, left-hand side, and for the experts, there is a neoclassical production function that converts any leftover resources that you haven't committed to either hybrid or fighting efforts into more resources tomorrow. Think of it as your industry in your country. Okay? So that's basically what Blotto is. And then we obviously populated this general idea with inputs. So the mechanics are all from standard game theory. If you don't know the buzzwords, just believe me, that's what's in the literature. So for attrition, we have Lanchester equations back to 1916, but these are still used in the German Gefechtssimulationszentrum des Heeres to power their Zira model, so they're in modern use today. We have a ratio contest success functions for force multipliers, which we take from the lobbying literature, and we have a neoclassical production function, as I already said, for the industry. And then, after I've written all the equations and programmed a Python example for it, I needed to do 3 more steps to implement this program. First step is to calibrate the parameters in the model. That took quite some time. There are a few very pertinent facts that came out of my study of the literature. For instance, the daily attrition rate of a larger formation, by which I mean division and above, is 0.35% of the formation's personnel. That has been consistent from World War II until the Yom Kippur War. It's very well documented by publications from the Rand Institute. Very consistent. And what that means that, well, you know the rule of 72? If something grows at X%, it doubles in 27 by X periods of time. So this is 0.35% is 1/3 of a percent. So this halves in 72 divided by 0.33 days, which is 210 days. The actual figure is, if you do the math, it's 196 days. So your larger formation that you put in one of these dimensions will be at 50% Kampfkraft or combat strength after 196 days, or about 1/4. And the professionals in this room, so all of us, know what we call a larger formation that has 50% of its combat strength. It's used up or nicht mehr kampfkräftig, and we normally take it out of service if we can and replace it. That's in Blotto. So if you have a force level of 10 in one dimension, after 1/4, which is our unit of time, that will be 50%, it will be down to 5 units. And your main decision is how to reinforce these units. The Q domain does not attrit. That's my idea of depicting the computer programmers and hackers. My kind of physique was sitting close to the heating back in the home country, obviously wreaking havoc on the enemy's command and control. So that's the idea here. Also from the literature, it takes about 400 days of convalescence until you can recommit a soldier who's been taken out of combat. That's 3/4, a year, basically. So that also is in the building. And the final thing that I need to look at is how much of your resources can you spend on warfighting before your industry shrinks, okay? So which percentage of the GDP can you really commit to warfighting? I looked hard at the Ukraine and Russia. Russia says they spend 6.1% of their GDP on the defense budget. I don't believe it for a second. For the Ukraine, we have estimations that they spend about half of their GDP, a little less, but they also receive subsidies from Europe. So I settled for 30%. So 30% is the resources that you can spend each period in Blotto, keeping your production at the same rate. If you spend more than 30%, you will have less resources, fewer resources next period. If you spend less than 30%, you have more resources. Okay, I'm doing fine time-wise. We're almost done explaining Blotto. There's two ways of winning Blotto. One is to have more than 3 times your opponent's military strength in any of the 3 domains. And the second one is after 3 years, the game's over, and the person with the higher resources, the higher GDP wins. So there's an economic victory and there's a military victory in Blotto. Okay. Now, for this to be a laboratory, we need to look at hypotheses. This will be in the paper. I would have to explain quite a lot about rationality, irrationality, psychology, and so on to really get you into this. The short takeaway is that it's not so easy as it seems because there's no dominant strategy. Okay, a dominant strategy is something that makes you worse off regardless of what your enemy does. Wir nennen das in Deutsch eine abwegige Möglichkeit des eigenen Handelns, for those who trained in the German or Austrian forces. And that is basically not existent in Blotto. I looked very hard, and it's very hard to find, even in commercial war games, such simple dominant strategies. That would be simple. No one would really pick them, and if somebody picked them, he wouldn't be rational, which would be a result. But it's not that easy, and then we have a lot of other things that I wrote down for you that you might look for. Okay, ready? 4 minutes of results presentation. So, we ran that at Win24. And the reason why my paper isn't ready yet is simple. The commercial firm that programmed Blotto for the internet made a mistake allowing for negative force deployment. And some people really found out rather quickly at Win24 that you can boost your GDP by sending negative levels of forces into the various domains. Now, you probably recognize that our political masters would love to be able to do that. But it's simply not possible in the real world. And we didn't discover this because my team was only playing normal things. We never shock tested the system, but the public did. And so basically I had to scratch everything until early September. And then 2 colleagues of mine, the commander of the logistics school of the Bundeswehr and the commander of the Führungsakademie of the Bundeswehr helped me, good friends, and they ordered their students to play Blotto, which means that in 4 days we came up with a total of 372 valuable completed sessions. So that's 372 games, that's okay, that have been completed. There's a lot more that have not been completed because people dropped out, lost interest, or their internet connection, I don't know. These are taken out and we only look at the completed sessions. So, brief results. First thing, allocated versus deployed. This is talking about dimension 1. The left graph shows the distribution of the commitments over time, and the right-hand side shows the level or the distribution of the deployments over time, and you see that commitments go up and deployments go down. That's the effect of the hybrid activities, because it takes more and more and more and more promises. So first a brigade, then a division, then a whole corps, and at the end an army group to achieve the same level of force commitment to the theater. So that's normal. Next, military aggressiveness versus economic thrift. That is interesting. I distinguish between the military victories, which are about 2/3 of the population, and the economic victories, and I was expecting that the military victories would have a higher level of commitment than the economic victories, but that is basically, as you can see here, these are the same scale, so I fiddled with the machine until they were the same scale. This is basically not the case, not in a significant way. Okay, so both types of victory increase their announced reinforcements over time and consistently with each other. So interestingly, I didn't find any difference between the two. Force multipliers and hybrid efforts. This is also rather interesting. You see the distribution of allocations to the cross-sectional dimension, so to cyber over time, and the political effort over time. Political effort is pretty much low and very, well, spread out. So it's very heterogeneous distribution, as you can see from these box plots. And these are the medians. The white lines in the middle of the boxes are the medians. You see that that fluctuates over time. So it's not consistent behavior. And the very interesting thing is that the deployment to Q dimension goes up over time. That is irrational. At least I'm pretty sure it is irrational. Why? Q doesn't attrite. So you don't lose any hackers. Because of that, it seems more rational, if I may say so, at that point, to invest early on in hackers, because they will be used as force multipliers over a longer time. So, and then of course we have a panel regression analysis for experts. I won't, this is basically for capturing your captatio benevolentiae, yes. I also have a complicated type of analysis. We have a panel here, which means we have individuals that we observe over time. So all the games are individuals, and then the rounds are the time factor. So I can use fixed effect models, which treats each session as a different entity to analyze this econometrically. And what I see at this level of analysis is I don't see any main efforts. Basically, all the signs are positive. That means all the variables, which are highly significant, move along with each other in both models considered. So if you invest more in dimension 1, you also invest more in dimension 2. And all of us learned, even the young ones, because that's taught in the first semester in officer school, that you build your Schwerpunkt, your main effort, by denuding some areas and investing your forces into the other one, that you seek the decision in. And that's not what we see here, which is strange because all of the players were military professionals. And I also see that tradition and hybrid are complements. So people who use traditional strategies more, traditional deployments more, also tend to use hybrid more. I expected them to be substitutes, so that there would be one type of player who more heavily invests in hybrid, and the other type of player who more heavily invests in metal. This doesn't seem to be the case at that point, but this, I've only talked with this data set for 3 days, so this is rather very early days. Okay, if I break this down to the individual level, the problem is that I lose degrees of freedom rather quickly. So, let us conclude. That's the summary. It was an example for how I think we may do research on research on wars in the future using war games as simulations to find out how military leaders actually behave in strategic situations. Qualifier, only when we abstract away from the threat of losing your life or of being heavily wounded in combat. So this is never going to work for the infantry platoon leader in the front lines. That's just not possible. But at the strategic level, we can think about using this kind of analysis. Okay, what am I going to do? Well, I keep the game running and the data coming because I need more data points to distinguish between the various effects that I briefly mentioned. And then we'll deploy it in the laboratory, which means we'll change the parameters, telling people about the change in parameters. So the economy will become more productive, or dimension Q will become less effective. We can change all that. The political scene can be more productive. And then we'll look at partners. So we look at diets of players, player 1, player 2 in one game, the aggressor, the defender, and we look at how they behave, and then I'll write up the book. Okay? That concludes my presentation, except for the final idea. This is the QR code. Take out your smartphones, for Christ's sake. Get the QR code and join the Blotto game. Thank you very much for your attention. And back to you.